And so next we're going to discuss what it means to rotate a point about another point. And what we've got here is an XY plane. We've got our x-axis and we've got our y-axis. Okay, and we've got a point which we're going to call A. For the moment, only pay attention to this point here, A. That is at coordinates 8, 5, which is our x, y coordinate. And we're going to want to rotate this point A around the origin, what we call O, which is at 0, 0, which is right at the center of this graph here. So what do we mean by rotate? Well, the definition of rotation is to move an object in a circular motion around a given center point. Okay, so this is the center point. The origin is the center point. In this example, we're going to rotate point A around O. So rotation means we move it in a circular motion. So let's see what all the possible points are where A could be moved to. Okay, so I'm going to take my compass, which is a great way to figure out and represent circular motion. I'm going to put my starting point of my compass at the point where we have the center point. Okay, so the center point is always where you put the sharp point of the compass. And then I'm going to adjust the width, which I've done, so that it's exactly the distance between A and O, between A and the center point. And now with this compass, I'm going to trace out a circle. Okay, so these are all the possible locations where A could be rotated. Just having problems digging my compass in. I know we've all got the same problem sometimes with the compass. Okay, let's finish making the circle. Okay, so what we've got here is now the circle of all points that A could be rotated to. Any point along the circle, A could end up. But for now, we're mostly interested in one specific type of rotation, which is a rotation of a multiple of 90 degrees. So this is why we've drawn the line from O to A, and then we've drawn a line that's perpendicular to it. So that you can see this is a right angle, and in fact all of these angles are right angles, aren't they? These are two perpendicular lines. So that to go from A to this point was a rotation of positive 90 degrees. Okay, it was a counterclockwise rotation of exactly 90 degrees when measured at the center point. Let's just also remember that positive 90 degrees rotation is the same thing as a negative 270 degrees rotation, so they're both the same. Note that that takes point 8, 5 directly into point negative 5, 8. A 180 degree rotation, which is going all the way from here to here, which is the same thing as a straight line through the origin, is the same thing as a negative 180 degrees rotation. So positive 180 and negative 180 are the same. And that rotation would have taken the point 8, 5 into the point negative 8, negative 5. And our last rotation that we're going to look at is going 3/4 of the way around a circle to this point here, so we would call this a positive 270 degree rotation, or it's also 90 degrees clockwise from point A, so it would be a negative 90 degree rotation. They're almost synonyms, okay? So when we say positive 90 degree, we could have just said negative 270. It means the same thing. Positive 180 and negative 180 mean the same thing here, and positive 270 and negative 90 mean the same thing here. Notice that the positive 270 degree rotation takes the point 8, 5 and brings it to the point 5, negative 8. I encourage you to double check the point locations on the graph. I also encourage you to do your own graph. In fact, you could use a point other than 8, 5, construct a line from O to A, find the perpendicular, draw the circle, and find out which points are at 90, 180, or 270 degrees rotation from A. You're going to find that regardless of what point you start with, let's call it X and Y, when you do a positive 90 degree rotation, you're going to end up with negative Y comma X. So let's check and make sure that works here. So here 8 must be the same as X, right? Because it's coming first. So 8 is X, and here X is supposed to come second, and 8 goes second. Okay, so that works. Let's check 5. 5 here is equal to Y, and according to this, negative Y is supposed to come first. So that should be negative 5 coming first, which is true. Okay, so if you go through that for each one of these points, you'll find out that we are rotating from A. As we go in 90 degree increments, we're starting with X comma Y, then we're moving it to negative Y comma X, then that's becoming negative X comma negative Y, and finally it's becoming Y comma negative X. Okay, and you'll see that if you try putting 8, 5 in each of those ordered pairs, you're going to get exactly the coordinates that we get for each of these 4 points.